The Wright Military Flyer belongs to the earliest military aviation period, when armies were still deciding whether an aircraft was a useful machine or only a dangerous experiment. Its importance is not measured by speed, armor, radar, missiles, or combat victories. It matters because it helped prove that powered flight could serve military observation, training, communication, and reconnaissance. In this stage, every engine run, takeoff, landing, and repair taught officers what aircraft could and could not do. The Wright Military Flyer was an early military aircraft built by Wright Company and the Wright brothers. It was used by United States, and its role was early military trainer, reconnaissance demonstrator, and experimental observation aircraft. Its first flight history is recorded as 1909 military acceptance trials, based on the Wright Model A design, and it entered service or military evaluation around 1909 with the U.S. Army Signal Corps. Known aliases and related names include Wright Model A, Signal Corps No. 1, 1909 Wright Military Flyer. The aircraft should be understood as a pioneer design, not as a mature combat platform. Its crew arrangement was two, with pilot and passenger or observer seated upright. Its practical mission was demonstration, training, observation, and proof of military aviation utility. In modern terms, it was closer to a flying observation post and training laboratory than a fighter or bomber. That is why its story belongs at the opening of a military aviation archive. It shows the moment aircraft began entering military thinking. For the officers who watched these machines, the key question was not whether they could defeat an enemy aircraft. Dedicated air combat barely existed. The question was whether a fragile powered machine could launch, climb, turn, observe, return, and be prepared for another flight. That made reliability, visibility, field repair, and pilot training as important as any headline performance number. The Wright Military Flyer was built because early military services needed proof. Balloons could observe from fixed positions, cavalry could scout on the ground, and telegraph or visual signals could move information, but none of those tools provided the same promise as a powered aircraft. A machine that could cross terrain, look beyond the front line, and return with information offered a new form of reconnaissance. The designers and military users did not yet have mature doctrine. They had engines that could fail, fabric wings that needed constant care, wooden structures that reacted to weather, and pilots learning by experience. Development therefore focused on making the aircraft controllable, repeatable, and useful enough for training or observation. The requirement was simple but difficult: lift a crew or pilot, maintain enough speed and altitude to be safe, and land without destroying the machine. There was also an institutional problem. Armies had to create rules for selecting pilots, inspecting aircraft, moving spare parts, building hangars, and deciding who controlled aerial information. The Wright Military Flyer helped expose those questions. A successful demonstration could support funding and training, a crash could slow enthusiasm. Early military aviation advanced through this uneven process of experiments, public demonstrations, official trials, and small purchases. The design of the Wright Military Flyer reflects the technology of early aviation. Its power plant was Wright four-cylinder piston engine driving two pusher propellers by chains. Its structure was wood, fabric, wire-braced biplane structure, which meant wood members, fabric covering, wire bracing, and careful rigging were not minor details, they were the aircraft's strength and safety system. Its control method was wing warping roll control, forward elevator, and rear rudders. Later aircraft would use stronger airframes, enclosed cockpits, metal structures, radios, instruments, and standardized maintenance, but this aircraft belonged to a period before those features were reliable or common. Speed, altitude, range, and endurance were limited by engine power, propeller efficiency, fuel capacity, weather, and pilot skill. The wing was not just a lifting surface, it was a flexible structure that had to remain aligned under load. The aircraft carried no radar, no modern sensors, no avionics suite, and no guided weapons. Its systems were the engine, propeller, wing, elevator, rudder, bracing, controls, and the pilot's judgment. Maintenance was part of the design story. Fabric tension, wire alignment, propeller condition, engine cooling, fuel flow, and control response had to be checked constantly. A small rigging error could change handling.
A weak engine could turn a routine climb into an emergency. Early pilots also flew with limited instruments, so the aircraft's physical behavior, sound, vibration, and attitude were part of the information system.
The Wright Military Flyer did not carry weapons or systems in the way later military aircraft did. Its main capability was information. A pilot or observer could look at roads, fields, troop movement, rail lines, ships, artillery positions, or terrain from above. That was strategically important because early 20th century armies were beginning to understand that observation from the air could change planning. The aircraft could support training, reconnaissance, demonstration flights, route proving, and basic military evaluation. Some early aircraft in this period later carried pistols, rifles, small bombs, cameras, or signal equipment, but those were improvised or primitive additions rather than integrated combat systems. For the Wright Military Flyer, the important systems were the mechanical engine, propeller drive, wing structure, fuel system, control surfaces, and observer's view. Its capability was not destructive power. Its capability was giving commanders a new perspective before dedicated fighters, bombers, and reconnaissance types existed. That capability sounds modest only because later aviation became so advanced. At the time, seeing over hills, rivers, roads, and defensive positions could be decisive information. Even a short flight could reveal whether troops were moving, whether a bridge was intact, or whether terrain would slow in advance. The weakness was communication. Without reliable radio, information often had to be remembered, sketched, signaled, or carried back after landing. The operational history of the Wright Military Flyer is connected to no combat use, used for U.S. Army Signal Corps training and evaluation. In this era, even non-combat service mattered because militaries were learning how to select pilots, maintain fragile machines, build airfields, store fuel, brief missions, and recover from accidents. If the aircraft was not used in major combat, that is still an answer to its history. Its importance came from evaluation and training rather than battlefield effect. If it was used in early conflicts, its missions were usually observation, message carrying, scouting, artillery spotting, or basic bombing experiments. Crews faced weather, weak engines, poor instruments, uncertain navigation, and little protection. The aircraft's service life was short by modern standards because aviation technology moved extremely quickly. A design that seemed advanced in 1 year could be obsolete a few years later. That rapid replacement does not reduce its historical value, it shows how fast military aviation was learning. Operational use also showed that an aircraft was never just a machine in the air. It needed ground crews, tools, fuel, transport, storage, spare parts, and commanders willing to trust reports from above. Those support habits later became normal Air Force practice. In the pioneer era, they had to be invented through trial, error, and practical necessity. The strengths and advantages of the Wright Military Flyer were proof that an aircraft could be accepted and operated by a military service, simple enough for early training and experimentation, two-seat layout allowed observation and instruction. Its most important strength was educational. It showed what an aircraft could contribute to military work before doctrine, radios, cameras, air combat tactics, and specialized aircraft categories had fully formed. It could train pilots and mechanics, demonstrate reconnaissance value, and force armies to think about altitude, speed, endurance, maintenance, and observation as military variables. For the period, even modest performance was meaningful because the alternative was no aircraft at all. A successful flight could influence procurement, training schools, and the creation of early air services. The aircraft's advantage was therefore not domination, it was proof of concept under real military conditions. The weaknesses and limitations of the Wright Military Flyer were fragile structure and very limited speed, altitude, payload, and endurance, no practical weapons or combat systems, demanding controls and high exposure to weather and mechanical risk. It was fragile, weather-sensitive, lightly powered, and extremely dependent on pilot skill. Its payload was limited, its endurance was modest, and its altitude performance left little margin. There was little or no protection for the crew. Communication with troops on the ground was primitive, and navigation depended on landmarks, maps, and visibility. Maintenance required